Okay, welcome folks, and today we are going to see weights in Selenium. Okay, so today's topic is weights in Selenium. So this is what we are going to learn today. So before starting up with this topic, let me tell you the problem statement. What is the problem statement for this topic? Okay, while working on some pages or some websites, and while searching for particular web element, there are chances of getting no such element exception or maybe timeout exception. Okay, so these are the very famous exceptions you may encounter while writing your automation test script. So reason behind these exceptions are simply, if let's say when you will encounter no such element exception, so whenever the element that you are looking for is not available on the web page, or or it is taking or it is taking a lot of time. Please mute your microphone, it is disturbing me. So whosoever mic okay, Prajakta's microphone was on. So please mute yourself, guys. Okay. Okay, folks. So uh, when you are going to get an no such element exception, so whenever you are working with some web element and you are trying to find that particular web element on a web page, and the web element is not loading in a specified time, in that case you may get no such element exception. Otherwise, timeout exception can be occur. Okay, can occur at that point of time. So to avoid such kind of scenarios and to avoid our script ending or terminating abnormally, what we need to do is we should wait for that particular element or event to be occurred. Okay, let's say that your automation script is asking to click on particular alert. Okay, but that alert is not present on the web page right now, and it is taking a lot of time to load on the web page. So in that case, your Selenium script will terminate abnormally with an error message that no alert present. Okay, so this may be a case. So this may happen with the web elements, or maybe alerts, or maybe some images that are there on the web page, or any web element, obviously. So the requirement over here is how we can solve this problem first of all. Okay, how we can tackle this with these kind of situations. Okay, so let me tell you that whenever you are working with any web project, okay, where there are a number of elements on your web page and few of them are taking long time to load rather than other elements. Okay, in these situations you should obviously have to wait for those elements or events to be occurred. Okay, so our script should not move ahead before the element is present on the web page. So we have to uh, ask our script to wait for certain amount of time. Okay, so for that purpose we have certain waits in a Selenium. Okay, certain waits in Selenium we have. So we have to ask our script to wait or to halt for particular amount of time, or maybe particular amount of situations and everything, or maybe some state of particular web element. So we have to ask our script to halt or stop for particular amount of time. So this is what is required in simple words. Okay, so for that purpose Selenium have given us certain waits inside Selenium itself. So what are those? Okay, let us see them. So we have two weights in a Selenium. First one is implicit weight. Okay, first one is implicit weight, and second one is explicit weight. These are the two weights available inside Selenium. Okay, implicit weight and explicit weight. So we have to understand the one line definition of them first, and then we will start elaborating or start digging in the uh, entire topic or entire concept. Okay, so first one we have to start with the implicit wait. Implicit wait. Okay, implicit wait. It's a typo. Okay, implicit wait. So what implicit wait does actually? Okay, so it will implicitly wait for each and every event or each and every element which is been handled by the WebDriver instance. So far we have talked about that WebDriver instance is responsible to locate some particular web element. It is responsible to click upon some particular web element. It is responsible to maximize the windows, resize the window, or maybe it is responsible to open some another window. So we have seen that these many operations a WebDriver instance can perform. So obviously if we are applying a implicit wait, then this implicit wait will be applied for each and every action that we are performing using the WebDriver instance, no matter what operation it is. Okay, it may be a maximize operation, window maximize operation, it may be a find element operation, or some any kind of operation it could be. So for each and every operation, implicit wait will be applied. Okay, now let me write down the definition in a simple words. Implicit wait is attached to the WebDriver instance for its entire lifespan. Okay, or maybe entire lifetime. Okay, this is what implicit wait is. So it will get attached to the WebDriver instance for its entire lifetime, and whenever we perform any operation using the WebDriver instance, at that case implicit wait will be applied. Now what is mean by applying implicit wait? Okay, so simply wait will be executed before each and every operation that we are invoking using WebDriver instance. Okay, let's say we want to click on some particular web element, and we have applied a wait of 2 seconds. So obviously before clicking on that particular web element, wait for 2 seconds max. Okay, 2 seconds max. So here we have to understand certain terminologies inside waits, so that we can understand the waits very clearly. Okay, so what are the terminologies? Okay, here waits use this keyword most of the time, and that is polling time. Okay, polling time. So what is meant by polling time? So it is a polling time is specified amount of time where Selenium will go and look for that particular web element on the web page, whether it is present or not. Okay, let us take an example that let's say I have asked to stay you at some bus stop. Okay, and I have asked that one of my friend will arrive at the bus stop and by 4 p.m. or something like that, and you have to pick some parcel from my friend. Okay, and you have to give that parcel to me. Okay, now you are sitting on the bus stop, right? And yeah, you are just, you are very early, you have reached before 4 p.m. To the bus stop, and you are waiting for my friend. Okay, now you are at the bus stop and one bus will arrive. So obviously once the bus is arrived, okay, you will start looking that whether my friend is getting out of that bus or not. Okay, that is what you are going to check. So that bus will leave, then next another bus will come in picture, and then you will also start looking after that bus, and you will scan that bus for my friend, whether he is there in the bus or not. Again one bus will go, the next bus will come, and you are all again going to check for that particular friend of mine in that bus. So you are going to scan each and every bus after certain amount of time, but here the amount of time required to arrive next bus is uncertain. Okay, but what you are doing is polling. Okay, what you are doing is polling. means you are searching for your friend, my friend, repeatedly, okay, unless and until you find the friend, or maybe the time gets exceeded. So let's say that you were waiting for till 4 p.m. Okay, I have asked to wait you for 4 p.m. till 4 p.m. But my friend didn't arrive at that bus stop at 4 p.m. So at 4.5, okay, 4 p.m. and 5 minutes, you will leave that bus stop. Okay, you are not going to wait for that friend anymore. Why? Because the maximum amount of time is exceeded. So that was your maximum time to wait. Okay, so waits are certain phenomena where a programmer can halt or stop the entire script, okay, or entire automation script for certain amount of time, let's say 5 seconds or maybe 10 seconds. But if the element is not appearing inside 5 seconds also, okay, then we will surely get no such element exception. Okay, not timeout exception in that case. Okay, so if we are handling our script using the waits, then obviously we are going to get an no such element exception rather than the timeout exception. Okay, so what is polling time we were talking about? Polling time is a certain amount of time for which Selenium WebDriver will look for particular web element repeatedly. Okay, let's say after 2 seconds. So after every 2 seconds, Selenium will look for the web element, whether that element is present on the web page or not. Okay, so that is polling time. And what is maximum timeout? Is the maximum time that our script can wait. Okay, let's say maximum timeout is 2 minutes. Okay, so our script is going to wait for 2 minutes. Okay, and if that element appeared between that 2 minutes, then obviously the operation will be carried out on that element. If the element is not present or not appeared in 2 minutes of time, then Selenium script will throw a no such element exception, and it will end the entire script abnormally or terminate the entire script abnormally. So in that case, obviously you have an option of exception handling to handle such kind of scenarios where you are getting exceptions, but you don't know that what kind of exception you will get, because Selenium's exception hierarchy is something different than what we have in the Java. Okay, so they have a different structure over there, different classes are there, different child classes and so on, they are there. Okay, so in such sense, we can say that maximum timeout is there, okay, rather than polling time. Max timeout is there. Okay, max timeout. So these are the two phenomena that we have come to an end today. Okay, so what one was first one is the polling time, and second one is the maximum timeout. Okay, now let's talk again about the implicit wait. What is implicit wait? It is a wait attached to the WebDriver instance, and it will be invoked each and every time whenever you are invoking certain operation using the WebDriver instance. Okay, but here we have to specify the maximum waiting time. Okay, we have to specify the maximum timeout. Okay, let's say 2 seconds, 3 seconds, or maybe some seconds. And the default polling time over here is a 200 milliseconds. Okay, 200 milliseconds is the default polling time inside implicit wait. But this is not a fixed amount of time. Okay, it is not a standard time at all, because Selenium's website doesn't guarantees about this 200 milliseconds. So if you go for the Selenium's official website, that doesn't guarantees about this 200 milliseconds. Why? Because this standard polling time differs based on the browsers and their versions. So whatever browsers we are using, based on those browsers and their versions, this 200 milliseconds polling time may get changed. Okay, so but for the Firefox browser, the polling time is 200 milliseconds. So after each and every 200 milliseconds, implicit wait will go and check whether the web element is appeared on web page or not. Okay, and maximum timeout is the timeout when our WebDriver script will stop itself for finding the element. So that is the maximum timeout. If the element is present in that particular amount of time, then obviously it will perform the operation on that web element. If the element is not present in that particular time, then it will throw no such element exception. Now, how you can achieve the implicit wait? Okay, so simply invoke it using the driver dot manage dot driver dot manage dot timeout dot timeout dot implicitly wait. Okay, implicitly wait. Okay, and here we have to give parameters like, let's say, for and then time unit dot seconds. Okay, this is the example of writing the implicit wait. Now, this implicit wait will be attached to the driver instance. So whenever we are writing or wherever we are writing this line in our program, after this line, the wait will be attached to the driver instance, and that is implicit wait. And this wait will remain throughout the driver instance life cycle. So whenever we will call garbage collector on this driver instance, or maybe something else on this driver instance, or we are going to just terminate this driver instance, till that point this wait will be applied, and this wait will be applicable to each and every operation that is invoked using this driver instance. Okay, so here the maximum timeout is 4 seconds. Okay, why? Because we have specified the time unit as seconds, but default polling time is 200 milliseconds. So for here what will happen actually, so let me draw something over here. So we have this web page, right? And this is the button. Okay, this button is there on the website, but it is not clickable. Okay, let's say this button is not clickable, and we have our driver instance over here. Okay, which is going to look for the web elements. Okay, which is going to look for the web elements present on the web page, but this button is not clickable. Okay, let's say this is disabled for some amount of time. So after 30 seconds, you might have encountered certain websites where skip ad button appears, but that button appears after certain amount of time. Let's say 5 seconds, 15 seconds, or 10 seconds, maybe something like that. So the button is present on the web page, but that is disabled for certain amount of time. So this may happen with any element in your project also. Okay, now this is the WebDriver instance which is waiting for this OK button to be enabled so that it can perform click operation on this OK button. So I have applied the implicit wait over here for 4 seconds. Okay, now this WebDriver instance will look, it will first, in the first iteration, it will wait for 200 milliseconds. Okay, after sitting quiet for 200 milliseconds, at the 201st millisecond, what it will do, it will wake up and it will start looking for that particular web element, whether it is enabled or not over here on the web page. Okay, then if the web element is not enabled, then it is again going to sleep for another 200 milliseconds. Okay, then at the 401 millisecond, it will again wake up and it will look for the web element, whether it is enabled or not. If the element is enabled, it will perform the operation. If the element is not enabled, then it is again going to wait for 200 milliseconds. Okay, so that is what polling time is. That is what polling time is. Then now next 601, at 601 millisecond, it will again wake up and look for the web element, whether it is visible or not. If it is visible or enabled, then it will perform the click operation. If it is not enabled, it is again going to wait for another 200 milliseconds. So this WebDriver instance is going to sleep and wake each and every 200 milliseconds of time. Okay, this is the standard time for Firefox, but this time may differ depending upon the browser and their versions. Okay, but once the driver instance reaches the 4 seconds of time, obviously this driver instance will get sleep, okay, and it will say that array no such element is there, okay, no such element is there. So it is going to sleep for that after 4 seconds, and it will say that no such element is there, and your script is stopping, and it will terminate your program abnormally. Okay, this is what will happen in case of implicit wait, and this will happen for each and every operation that you are invoking using the driver instance. I hope this is clear to everybody. Okay, this is implicit wait. Okay.
Agnes, one question.
Yes, Rajesh.
So implicit wait, it will wait for the every element. Suppose I in a web page there are click operation, there is a cancel operation, different operation is there. So implicit wait for the it will wait for the every operation or particular operation which user want to be.
No, implicit wait will obviously wait for each and every element which we are invoking using the same driver instance. So I'll show you that how it is going to happen.
Okay, fine.
Yeah. So let us do it practically so that you guys will have an idea about it. Okay, so we have something over here. Okay, so let me just quickly write some program that we have already written over here. Okay. Okay, this is our program. Can you see over here? We are trying to open the Facebook, and we are trying to get the color, but we don't want it. Okay, so on the Facebook's website, let's say, let's try to open the Facebook website from here. Let's see what happens, what kind of behavior it does have. Okay, this is the website that we have. And here we have the code, right? But can we have an example where we can get that particular button which is disabled first and then it gets enabled? So once I remember that website's name, obviously I'll take the example of that website. But till that time, we are going to have something else over here. Or maybe something ICICI Bank website we can take an example of. Okay, nothing is disabled over here. Okay, we will take an example of the login button, or maybe first name. We'll try typing on this first name. So this is the input tag and its ID. We are not going to take ID because ID of Facebook's page gets changed constantly. So we will search it with a name. So let us try writing the X path for it. Okay, and we are getting the unique element. So let's copy this X path, go in our program and driver dot find element. Okay, then by dot X path. And let's invoke the send keys method on this. And here let's pass Avinash, for example. Okay, but let's say that I'm attaching the implicit wait to it. Timeouts dot implicitly wait. Okay, now can you see over here, this method, implicitly wait method, takes time and time unit. These are the two parameters this method takes, and this time is actually a long variable. Okay, long time and time unit. Okay, so these are the two parameters this method usually takes. So here we are going to provide time in long. Okay, so for now I'm going to provide, let's say, 4, and time unit dot. So we have different time units over here. Can you see? They are days, hours, microseconds, milliseconds, minutes, nanoseconds, seconds, and so on. So these are the time units we have. So we can choose the time unit as per our convenience. So for now I'm choosing it for seconds. So this will be your maximum timeout. Okay, this will be your maximum timeout is the 4 seconds. Okay, now this maximum timeout will get attached to each and every operation that we are invoking with this driver instance. Okay, so please mute your microphones, everybody. Rox12 has dollar. Please mute your microphone. Okay, so let's say I'm invoking one more operation with this driver instance. Okay, driver dot find element by dot xpath. Okay, and let's type something on this surname also. Okay, its name should be last name. Okay, so we are going to write the xpath over here. Input tag having name is equals to last name, and then dot send keys. Let's maybe ping like. Okay, so for both of these operations, operation 1 and operation 2, for both of these operations wait will be applied by default. Okay, so minimum waiting time here will be 200 milliseconds and maximum waiting time will be 4 milliseconds. So these operations, before invoking send keys, okay, wait will be invoked. So wait will be applied at least for 200 milliseconds for this operation. Okay, if this first name appears in 200 milliseconds of time, then obviously this wait will not wait, and it will type the key Avinash inside that first name field. Then again it will wait for 200 milliseconds for this wave element to appear, before invoking the operation. If the element is appeared, then it will type this surname. Otherwise, it will again wait for 200 milliseconds. If it appears, then obviously it will type. Otherwise, it is going to wait for another 200 milliseconds. So for all of these two operations, this wait is applied by default. So whatever operation you invoke using this driver instance, obviously for those driver instances, this wait will be applied. But let's say that I'm writing Chrome driver drv is equals to new Chrome driver. Okay, and now let's say I'm writing drv dot get. So for this driver instance, wait will not be applied. Okay, why? Because it is configured for the driver instance and not for the drv instance. But you cannot see it in action because 200 milliseconds polling time is very less to identify and see by your eyes, in simple sense. Okay, so can you see over here, for this drv, this wait will not get applied. Okay, this is not applicable. This wait is applicable for only driver instance. Okay, this is what implicit wait is. So let us try executing this assignment. So we are not going to open another Chrome browser. That was just for the sake of example. Okay. You can see browser is invoked and it is trying to open the browser. Browser is opened. It is trying to put the URL. Yep, URL is entered and it is waiting, and then it have typed Avinash and Pingley immediately. Can you see? So it haven't wait for 4 seconds. Okay, so this is the misconception that implicit wait will wait for 4 seconds by default. So whatever amount of time we have given, it will wait for that amount of time. It will not. Okay, even if the element is appearing before this time, it will perform the operation and it will just jump on the next. So it will not wait for 4 seconds for each and every operation. Okay, so it will wait minimum 200 milliseconds of time before invoking each and every operation, and maximum 4 seconds of time. So this is the max time and minimum time is 200 milliseconds. Did you get this point? Implicit wait. Okay, but here the drawback is implicit wait is attached to the driver instance entire lifetime, and it will be applied for each and every element even if it is not required. Okay, so what happens some of the time is your internet connection is slow, or maybe the computer you are working on is having a very low latency, so that you are receiving the packets in a very low rate. So in such situations, it may happen that some of the elements on your website are loading late. Some of the elements on your website are very late, are appearing very quickly. Okay, this may happen. So obviously, we are not going to wait for those elements which are appearing very quickly. Okay, whatever you say, but we have to wait 200 milliseconds if we are applying implicit wait. Okay, so that is the minimum time, that is the minimum amount of time which will our script hold for each and every element. Okay, if you calculate and if you sum up that time, then, and let's say you are executing hundreds of test cases in a day, and each and every test case is having let's say 10 or maybe 10 plus steps inside it. So in that case, it will become really costly for us to add 200 milliseconds of time for each and every operation that we want to invoke. So ultimately that will become a heavy task for us to wait for each and every element. Now what is our requirement is, let's say there are 4 or 5 elements on your entire web page which are taking a lot of time to load on the web page, but rest of the elements are appearing very quickly. Okay, in such scenarios we will wait for particular web elements only, or particular events only. Okay, and that operation, okay, that customized wait we can achieve using explicit wait. Okay, explicit wait. So what is explicit wait? Let's see. Explicit wait. Now both of these are classes. Okay, not this one is not class, this is the method. Implicitly wait, this is the method. Okay, and explicit wait we have. Okay, we'll talk about it. Explicit wait. Okay, so what is explicit wait? It is highly customizable wait. Okay, it is highly customizable wait. Now what are the things that you can customize? Okay, let's say that we have talked in terms of implicit wait that there is a default 200 milliseconds of polling time. Let's say if you want to change this polling time to 100 milliseconds. Okay, now let's say I want to change this polling time to 100 milliseconds. So I can do that customization using explicit wait, but that is not possible in implicit wait. Okay, then we have a timeout. Okay, as implicit wait does have. Okay, and that timeout we can specify that timeout obviously. One more thing that we can specify over here. Let's say while searching for particular web element, there is some uncertain exception that you may encounter in your entire project. That is uncertain, unexpected, obviously. So if you want to ignore such kind of exceptions, you can ignore them using explicit wait. So we can ignore unwanted exceptions using explicit wait. Okay, explicit wait. Let's say that you want to wait for particular web element only or particular event only. That also can be possible using the explicit wait. Okay, so we can wait for particular web element or its state or particular web particular event on web page. Okay, maybe alert or maybe opening a window or maybe something else like that. So we can wait for particular web element over here. So it is not required to wait for each and every web element that we are invoking using the driver instance, unlike implicitly wait. So ultimately, this is highly customizable wait you can see over here, okay, where we can ignore the exceptions which are unwanted, obviously. We can specify the polling time over here. Let me write. We can specify polling time using explicit waits. Okay, explicit wait. And okay, we can ignore unwanted exceptions. We can wait for particular web element or its state or particular event to happen on web page. Okay, so that is the highly customizable wait, and that is most recommended wait. Okay, let's say that your application is very fast and efficient, and the machine on which you are executing your application is very fast and prominent. In that case, it is recommended to use explicit wait. But where your machine is not that highly uh, customized or maybe prominent or maybe good enough, or your internet connection is very slow, or maybe the configuration of computer is very bad, or maybe the application you are working on or maybe under test is not that efficient and prominent to load on all the elements on the web page. In that scenarios, implicit wait is recommended. Okay, so sometimes this may happen that you are executing your test cases in a bulk. Okay, let's say 200 and 300 test cases you are executing daily. So while executing, this may happen that because of the overload, your machine start behaving slow. Okay, so it may load the items very slow, or maybe something else happen in between. So connection speed, internet speed may get slow, or maybe your RAM is getting full each and every time, or maybe any reason can be there. So in such situations, it is recommended to have implicit wait, so that it will wait for that amount of time for each and every operation. But where you have a very good configuration of your machine and internet and everything, and your application is also prominent, in that case it is recommended to use explicit wait. Now we can achieve explicit wait in Selenium using two classes. Okay, we can achieve explicit wait in Selenium using two classes of Selenium. Okay, what are those classes? Let us see. So first one we have is WebDriver wait. Okay, this is one class we have using which we can achieve explicit wait. This is class. Okay, and then we have fluent wait. These are the two classes that we have. Okay, using these two classes, you can achieve explicit wait. Yeah, simple, very simple. So to achieve this explicit wait, we have to simply create the instance of one of these two classes. So we'll see that what is the difference between the two of them. Okay, so simply create instance of one of these two classes. and then customize your wait using the different methods available in this class, and you're good to go. So now your weight will be applied for that particular wave element only and not for all elements. So let us try achieving the explicit wait. So let me comment this. So let me write over here, below is example of implicit wait. Okay, now let me comment this line. Okay, it's commented. Now let us configure the explicit wait using fluent wait class. Fluent wait is equals to new fluent wait, and here we need to provide the driver instance. Okay, now this is the wait instance, and we can apply this wait instance on any web element that we want to wait for. Okay, but before applying this wait instance to particular web element, what we will do is we will configure this first. Okay, so how we can configure them. So we have talked about configuring the polling time. So let us try to configure this for polling time. So we have a method called as polling every. Okay, can you see this method also takes two parameters, that is long duration and time unit. So let's say I want to specify polling time as 100, and here time unit dot milliseconds, let's say. That's it. So our wait is configured for 100 milliseconds. Now our polling time, default polling time will be 100 milliseconds for this driver instance. Now let's say I want to ignore some exception which may occur in between. So I can call this method ignoring. Can you see this method? Ignoring. And now this method takes argument as exception class. Okay, so what kind of exception we want to ignore? Let's say timeout exception. Timeout exception dot class. Okay, this is the exception that we want to ignore while waiting for particular web element. Okay, so we have configured for ignoring the timeout exception during the wait. Okay, now let us configure the maximum waiting time. Wait dot with timeout is the name of method. With timeout, can you see? With timeout, here again it takes two arguments, that is duration and time unit. So let's say 4 seconds again. So this is the maximum timeout that we have. That's it. It is configured. Now let us wait for particular web element to appear. Okay, so wait dot. Now until is the name of method that we have to check for the particular state of particular web element. Now this method takes parameter as expected conditions class instance. Okay, expected conditions. Can you see expected conditions is the name of class, as well as expected condition name is the interface. Okay, it is a name of interface also, but we require is a class. So you should remember this, because interviewer may confuse you at this point, whether you have used expected condition or expected conditions. So it is expected conditions and not expected condition. Okay, expected conditions. And if you hit dot, you can see the static methods of this class. Now what are the static methods? Can you see over here? Alert is present. What is the name of method? Alert is present. So this wait will wait for alert to be present on the web page. So unless and until the alert is present on the web page, this wait will poll for every 100 millisecond. It will ignore the timeout exception. It will wait for maximum 4 seconds for the alert. Okay, this is the case over here. So this is the simple method to wait for a particular alert. Okay. In the same sense, obviously, we can use some other methods. We have lots of options in this class. Okay. We have add, let's say I want to, ignore some more exception over here. So I can mention them over here. An exception with the logical and condition of the given list of conditions is each condition is checked until all of them return true or not null. So obviously whatever exceptions that we are facing while loading our script, those exceptions can be checked over here by this method. Then attribute contains, so let's say that there are certain web elements on your web page which has 5 attributes, but 2 attributes of them are appearing late because of some or the other reason, or maybe the developer have created it that way. So ultimately, for such kind of elements, you can use this method where attribute is having certain value which is appearing very late. So attribute contains is again overloaded method over here. Then attribute to be, okay, an expectation for checking web element with given locator has attribute with a specific value or not. That is what you can check with this methods. Then it is again overloaded over here. Then element selection state to be. So we are going to check whether the state of particular web element, selection state of particular web element is appeared or not. That is what we are going to check using this method. So we have a lot of methods over here. Okay, frame to be available and switch to it. Okay, so obviously it will look for the frame to be available. Okay, and if the frame is not available, it will wait for that amount of time for the frame only, not for all of the elements. Okay, so here we have to mention the actual operation. Frame to be available and switch to it, and frame to be available in invisibility of. So we have to mention the locator of the web element over here. So this method will check for the visibility and invisibility of some particular web elements. Then again, invisibility of all, invisibility of element located by, and by instance we have to pass to this method. Then a lot of methods. JavaScript throws no exceptions. JS returns value, not number of elements to be. Okay, let's say we want to search particular number of elements to appear on particular web page. Then obviously you can use this method where you can specify that 10 links should be there, or maybe 10 buttons should be there. So you have to specify the button and then number of items that you are expecting. Then number of windows to be, so int expected number of windows that you are expecting. Then presence of element located by, okay, so it is simply an expectation for checking that an element is present on the DOM of a page or not. So if the element is not present, then obviously it is going to return us the web element if it is located. So if it locates the web element, it is going to return that element to us. So each and every method is having different return types over here. So we should be very careful while using the methods. So we have lots of methods over here for each and every operation, each and every state that you may encounter while automating your project. URL contains, so let's say that you want to check the content of the URL for particular amount of value or particular string pattern. In that case, obviously you can use this method. Title, for checking the title, for checking URL, for checking visibility of web element, for checking state of web element, for checking presence of web element, for checking some attribute of web element. We have method for each and everything inside expected conditions class. Okay, these methods are not inside Fluent Wait or WebDriver Wait. These methods are inside expected conditions class. Okay, so we can use one of these method and we can wait for that web element only. Okay, whatever element we are locating. So let's say let us use this method, frame to be available and switch to it. So we have to write the locator over here by dot maybe ID, because frames mostly have an ID. So we have seen an example of frame. So we haven't learned the frame, or maybe switching to the frame, so you guys will not understand what I'm trying to say. Okay, so we'll take some other example over here and we will wait for that particular amount of time. Dot, let's say alert is present, but most of the website doesn't have alert nowadays. And let's say attribute contains, okay, attribute contains, and then by dot, let us write something over here. Okay, now can you see over here we have, okay, let me delete this one. We have this first name over here which has different attribute like text, class, input, class, and the name, data type, and area required, placeholder, area label, first name, and so on. So we will check for this attribute, that is first name. Okay, so here I'm going to write by dot xpath, and we are going to check for input tag which has name is equals to this first name. Okay, and what is the attribute that we are looking for? Obviously first name, right? First name, sorry, attribute is name and its value is first name. So okay, so let us say that this attribute name is appearing late rather than rather than these all attributes that we have for this input tag. So this is the one attribute name which is appearing late. This is what we are considering for now, for the sake of example. So now this wait, can you see over here, this wait will be applied to this element only, okay, and not these two elements. For these two operations wait will not be applied. These two operations will execute normally, but for this operation obviously the wait will be applied. So this is explicit wait achieved using fluent wait. Okay, let us open this class fluent wait. Can you see this is the class fluent wait? Okay, and if you traverse this point at this point, then you can see um, the description of this fluent wait over here, and it says that it is an implementation of the wait interface that may have its timeout and polling interval configured on the fly. So obviously we can configure the timeout and polling time using the fluent wait, and its parent interface is wait. So wait is the interface which has been implemented by fluent wait. Each fluent wait instance defines the maximum amount of time to wait for a condition, as well as the frequency with which to check the condition, that is polling time that we have talked about. Okay, so it can also set the frequency as well as the maximum amount of time to wait for. Furthermore, the user may configure the wait to ignore specific types of exceptions whilst waiting, such as no such element exception, or maybe something like that, when searching for an web element on the page. So this is the example that they have given on their official site and official code also. So you can have a look at it. I'm not going to read this for you. Okay, the same thing we can achieve using the WebDriver wait class. WebDriver wait is equals to new WebDriver wait. Okay, so we have to import this class. and we have to specify some amount of time over here. So the same thing that we have done using this wait over here. So let us open this class and let us have the look at the description. Can you see? WebDriver wait class extends Fluent Wait. So Fluent Wait is the parent of WebDriver wait. Okay, so WebDriver wait doesn't have its own methods. It uses all of the methods of Fluent Wait itself. So it actually doesn't have any method of itself here. So can you see over here? It has only the overridden methods. Can you see? It has only constructors inside it. 1, 2, and 3 constructors are there. This one is the class. Okay, so 3 constructors are there in this class, and it obviously extending the Fluent Wait. Its parent is Fluent Wait. It is using all of the methods of Fluent Wait itself. Okay, it doesn't have its own method. It does have only constructors. Now what is the purpose of creating WebDriver wait class? Why Selenium people have decided to go for the WebDriver wait class? Okay, so the reason they have given over here, this is a specialization of Fluent Wait that uses WebDriver instances. Okay, now this is the specialized version of the Fluent Wait where WebDriver Wait actually uses the WebDriver instances rather than the particular web elements. Wait will ignore instances of not found exception that are encountered by default in the until condition and immediately propagate all others. Okay, so it is going to ignore the instance of not found exception. Okay, let's say no such element exception, not found exception, whatever kind of exceptions are there. These this exception or instances of such kind of exceptions will get ignored by the WebDriver wait. Okay, and by default in the until condition and immediately propagate all of them. So whatever exceptions which are encountering in the until condition will get propagated, but it will obviously ignore the not found exception. You can add more to the ignore list by calling ignoring, obviously, because the ignoring method is provided by the Fluent Wait. Then it has 2 parameters over here. We can see the driver. Okay, the driver instance to pass to the expected conditions, and then timeouts. The timeout in seconds when an expectation is called. Okay, so here we can see that it has one constructor which is actually taking a WebDriver instance and the time that they want to associate, but time out should be in seconds over here. You don't have choice to configure that timeout over here. So it by default takes the timeout as 10 seconds over here, or maybe whatever amount of time you are mentioning over here, that time will be taken in terms of seconds only. So here I have specified a default timeout is 10 seconds. Okay, 10 seconds, but we can set the polling time using the polling every method. But by default, if you are not using the polling every method, this is going to set for 10 seconds max timeout. Okay, and then we have this one constructor over here, and here you can specify your actual polling time in using the sleep in millis, the duration in milliseconds to sleep between polls. So that is what the polling time is. So you can use this constructor to avail the polling facility also. But can you see they are constructor specific, where you can actually construct the wait using the WebDriver wait itself. So you don't have to call the methods. They can simply be called using the WebDriver instance, and whatever the parameters you need, you have to pass them over here. Here we can see WebDriver wait and then clock, sleeper, maximum timeout in seconds, sleep timeout, and then superclass constructor is being called over here. Then with timeout, this one parameter is there, polling every, ignoring. So altogether, WebDriver wait, if you use WebDriver wait instance, by using its constructor, you can directly construct the object. So no need to call the methods explicitly if you are using WebDriver waits instance. Okay, but if you are using Fluent Wait, you have to explicitly call the methods of your choice. That is the difference between both of them actually. So choice is yours. Obviously, if you want to directly construct the things using the constructors itself, so you can, in that case, you can go for the WebDriver wait. But if you want to configure the methods and configure the tactics on your own, then it is better to go for the Fluent Wait in that case, where you can have a choice of calling the method of your choice. So that is what the difference between WebDriver wait and Fluent Wait. But using those two classes, we can achieve explicit wait. Okay. So this is all for the day. If you guys have any questions, please ask.